Okay, so this is our day 22 of doing Leetcode daily until I get a job. So we'll be doing today some other sheet because the major topics we have already covered from the existing sheet, that was neat code. So I'm not gonna go like to all the topics of it because some of the topics are irrelevant from the interview perspective, and right now we should focus on that only. If once we clear some interviews and all, after that we can do it for our knowledge and for our like betterment. But for now, let's just focus on the interviews only. And for that thing, this is one of the sheet, blind 75, that we can like, that's basically purely interview based or interview oriented. And like I'm not sure, but I have also heard about one more sheet which is uh, maybe grind 75 something. Okay, yes, I guess this one. Okay, wait a second. How to filter them out? Let's see, let's just sort them on the basis of difficulty, and let us put the hard on the top. Okay, we have some questions here which we haven't done, so let's do the hard ones first. Like you can see, some of them we have already done and some we have not. So let's start from this merge case sorted lists. Let's see what we have in that. So here we are given with the array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Like 145 is sorted, 134 is sorted, 26 is sorted, and then we have to give a final sorted linked list into a single one. They are three different, we have to give a single one. So what we can do in this, see, one way the brute force approach is simple, that we just go in all the lists one by one, take them and uh, like put them in a single linked list and then sort that linked list. That's a different question, sorting a linked list. Okay, and so yeah, what one thing we can do this, that's a purely brute force. Like one thing we can do is like taking all taking out all the values of the numbers or nodes, making it as a vector, and then creating an all new linked list with all those numbers by sorting them. Okay, so that's just the brute force approach, but I don't think that will be the correct solution of it. uh, there's nothing given, like there's no constant on time complexity, but like let's see, let's just try something better, that what we can do in this case. uh, okay, so we have to take these three and return a sorted overall linked list. So see, what's the way of doing this is, like let's just say we have a number of list, and what will be the first element of the final linked list? This is, let's say, the final linked list which will be returning. What will be the first element of it? The first element will be the minimum of first element of all the linked lists in the lists array, right? The minimum of 1, 1 and 2 will be the first element here. Either it is this one or this one, doesn't matter. Okay, and after that what will happen is, from, wait, yeah, from whichever list we will take this one. Let's say we have taken this one from this list. Now uh, three pointers will be, one will pointing here. Okay, now the minimum of these three, 4, 1 and 2 will be here. So next is again 1. Now minimum of this one is done. Of minimum of 4, 3 and 2 will be here. So 2 will be here now. Now minimum of 4, 2 is come. Okay, 4, 3 and 6. 3 will be here. Then 4, 4 and 6. So again it will be 4. Let's say we have given this 4. out of 5, 4 and 6. So 3 are remaining, so it will be 4, 5 and 6. Okay, these are the things. So now what we have to do in this is, see, we basically have to take out the minimum. And how can we take out the minimum? What's the best possible approach we can take while taking out the minimum out of a given data? Right, this is min heap or priority queue in C++ STL language. So basically we are gonna go with min heap and see, but it is a linked list. How can we use the min heap? Right, you will ask this now. See, how we can do that is, we have a min heap and min heap returns the minimum element. Right, we can extract the minimum element from the priority queue of min heap by just, it's the front element, it will always be minimum. Okay, we can extract the minimum in most optimized time. I'm not sure like how much time, maybe login, I'm not sure, but yeah, the minimum time. So but this is a linked list. How can we insert them in a min heap and then work with it? See, so what we are going to do is we are going to form a priority queue. Okay, priority queue. What will be stored in the priority queue? Priority queue basically, what, whenever we insert any element in the priority queue, it will sort itself in such a way that the minimum will be again at the top. Right. So what we will insert is we will insert a pair. What will the pair contain is, first is the value, means the integer value of the nodes, first nodes of all the list initially the priority queue will be having the first node value of each list, each small list like 1 2 3 all the list, and second is the node of its head. Okay, node star. This is what we will have a pair, and we will have a priority queue of this type. We will insert in the priority queue these three things, 1 1 and 2. Now we will uh, like uh, iterate through that priority queue, like while priority queue is not empty, we are going to run the loop. Every time we will take out the top element, we will we will make a node out of it, and we will insert that value into it. After that we will pop it. Okay, and we will again insert in the priority queue if there is anything next to that element which we have just extracted from the min heap. Let's say we extracted this one. Okay, then if is there anything next to this? Yeah, 4 is there, so we will insert 4 and the nodes next, any fourth node here in the priority queue. If it's the minimum, it will come to top. If it's not, the minimum will come to top. Okay, so that's how we can work with it. I hope this should work. So let's just try to code this. If our approach is fine. Okay, battery is low. Okay, so let's just try to make this thing work. So what we have is the firstly and lists dot size 1 and there's so much n. Okay, after that we will form a priority queue. See if okay, if the list is empty, we have to return empty. Fine, that means list node. Okay, if n is 0, we will just return null. Okay, null is not written like this, I guess this is null. So now we will take a priority queue, that's the min heap. This is how we write the min heap in C++. That's just a way of writing it. Okay, so it see, keep in mind we are talking about min heap, not max heap. So we are just not gonna do this. Okay, pair and list node star, we are not gonna do this. And now pq, the name of the list. This is a max heap. This is a max heap. Min heap has a more complex kind of we can say structure or syntax. Second thing comes is vector. Vector will also contain that same thing. What same thing? Sorry, yes, yeah, this should go here. Okay, and we should copy this pair. We will enter pair inside the vector, and again we will take the vector and copy it, and we can copy it again, and this will be a greater. Fine, this is I mean yeah, that's fine. So this is the syntax of min heap. We have to, like, obviously remember this thing in C++. If you want to easy keep the things easy, this is how we need to do the min heap. Otherwise you can implement the whole min heap using class and ha ha. Okay, so the next thing will be doing is, for all the list we will insert the first node in the priority queue along with its value. So for int I02 we will go to each of the lists, and what we will insert, so if there is a list, see, list can also be empty. So if there is a list existing here, if list I is there, then we will just pq dot push a pair. Pair में क्या है? First is the integer value. Integer value means lists I first node's value. Okay, and second thing is just list I. Correct. This is the way we will insert the first element of all the lists in the priority queue. Now on the top of the priority queue we have the minimum, we have the node with the minimum value. Fine, so we will make a new node, list node star head, which will be a new list node because we are going to make a new linked list, and let's make this as temp as the, which will be suggesting to head. Okay, it will be signifying head only. So now what we will be doing is we will be traversing the okay, so we will be doing what? We will be saving the front element, pk dot front, front or top, I guess it's top. Fine, after storing this top we will just pop this out, right? Now what we have is f. So if f's next exists, f f dot second, because the list is at second place, first is the value. Okay, we don't have to worry about it, the value will never be needed, it's just needed in the priority queue to sort itself. Okay, so f dot seconds, if there is a next existing to it, then we will insert it. What? pq dot push two things. What are they? F dot second next value, and the second thing will be f dot second next. Simple as that. Fine, we did it. After that what we need to do is we need to make the f as a node, right? So temp will be now, so there's going to temps next, it will be the next thing now again. Okay, sorry, temp next will be, sorry, temps next will be, we will return the heads next. Okay, that's how I usually work with it. Like, not a hard and fast rule, you can apply some other method, but that's how I work with linked list. I make a pointer to the head, and I will Firstly, go to the next. So I will return the heads next because head is null. Fine. So we will just do f dot second. Temps next is the current node which we are at, which we just popped out. Okay. Once we did do this, we will just go to the next position. Temp is temps next now. Fine. I guess, yeah. So we will just return the heads next. Heads next. Okay. Lister node star head. Bigger second. Fine. Temps next is f dot second. F dot second is it with the list. Okay. That node basically. That node. And we will move the temp to the next position now. And we'll go for it. Yeah. Fine, I guess. Let's try running this. Oh, it's not Q. It's PQ. Not dot will be this. Yeah, fine. So yes, we are good with this. Merge case sorted lists. Okay, so let's go to the next hard question, which is the find median from the data stream. What are the remaining basic calculator, maximum profit and job scheduling? Okay, how much we have done? 41 we have already done out of this grind, 75 also. So yeah, it's fine. Yeah. Okay. So next question will be, okay. There are two questions. I will try to do three questions at least. This find median from data stream and the maximum profit job scheduling and the basic calculator is also there. One we have done, three we are remaining. So we'll do one by one. Fine. So what's given in this question is that we have n jobs where every job is scheduled to be done from start time to end time, obtaining a profit of profit I. सो हमें हर जॉब के लिए स्टार्ट टाइम दे रखा है, एंड टाइम दे रखा है, और उससे प्रॉफिट कितना होगा वो दे रखा है. सो यू आर गिवन these areas. Return the maximum profit you can take such that no two jobs in the subset with overlapping time range. So without any overlapping intervals, we have to find the maximum profit we can achieve by doing the jobs, but no two jobs should be overlapping. Like these are there are four jobs here. For one job, start time is 1, end time is 3, profit is 50. 1 to 3, profit 50. 2 to 4, profit 10. 2 to 4, profit 10. And 3 to 5, profit 40. And 3 to 6, profit 70. So we'll do these two jobs, 1 to 3 and 3 to 6. They are non-overlapping, and that will give us the maximum profit. Fine. So how we can approach this? How we can approach this is that's basically something like we should pick the interval or not pick that interval. Okay, because if we pick that interval and then doing all the other things according to that, will it give us the maximum profit? Or if we do not pick this interval and then going according to it will give us the maximum profit. So basically it's a dynamic programming thing where we are not sure how to do things, so we just break it down in points. And that's also like the coin change problem. It is behaving like in coin change. We have two options: either we pick that coin or we do not pick that coin. You have one option, correct? So how to work with these two options is that if um, see we can do one thing here. We are given the start time, end time, and the profit. Fine. Okay, what we can do is if we just sort the start time, okay, and we try to find once end time. See, we are taking the first job. Okay, let's say we are considering the first job. I mean, we will decide now that we have to do this or not do this. So, okay, we will pick up 1 as the start time. Now find the end time for it. It is 3. So between 1 to 3, if we pick up this job, we cannot do any other job. Correct? So the start time of the next job should start from at least 3 or maybe more than that, right? Between 1 to 3, no other job we are doing should have a start time. So if we insert this 3 somewhere in this array, where it should be? It should be at min here after 1 and 2. Okay. So if yeah, they are. These guys let me lose my focus. I don't know. Okay, so 1, 2, 2, 3. Yeah, we can insert this end time here. After only this end, we can pick up a different job, and that too, whichever end time, start time greater than the end time of the first job. Correct. Now we have two options. Either we can do this job, either we can not do this job. So if we do this job, we will add the profit of this job to our final answer and call the function for the next thing. For the next index, we just have, see, for 3, we know that 3 can be inserted here. So we can call the next function with this index 3. Okay. We have to we have to pick up an index from the start time, which will like serve our question, and all the condition will be fine with it. Condition is what? That the intervals should be non-overlapping. Fine. Non-overlapping, yeah, we are good with it, because when this ends, only after this we will pick up a job. We will not pick up 2 because it exists between 1 and 3. So that's why we will call the function again. See, initial function call was like this. We were calling the 0 index, first start times, okay, and we just provided these arrays into it, and start time is sorted now. Okay, so we just provided 0th index. Now next time, if we consider this job, we will provide an index which is just next to where it can be inserted, where its end time can be inserted. And if we do not pick up, see, this is the case of pick. If we pick up this job, second case will be not pick up, means we do not pick up that job, we don't want to do that. What will be that case is, then we just skip this current case, like we did with the coin change. Like we did, if we took the coin, we will just minus it from the total sum we want to achieve, okay, and add 1 coin to the answer, that we are added 1 more coin. But if we do not pick this job, then we can just start with 2. We can start taking the case of 2. Let's find for the 1 index, or if I was passed there, I plus 1th index. Check for this now. And dp of ith case can be max of pick and not pick. Whichever case gives the best answer, dp will store that, and we have to find the dp. n jobs are there. ith job के लिए आंसर दे देगा अपने को, अब वही आगे की सबके लिए दे देगा, और dpn we need to find. And if we can also do memorization there, that if dpi exist and is not equal to what we initially put the values in the dp, let's say -1 array. Initially dp was a -1 array, and if dpi is not equal to -1, then we just return. Okay, because that is that case is already done, memorization, that's the thing here. Okay, we don't want to do the calculations for dpi again because that's already done. Fine. So let's try to do this. Okay, so how can we start with the solution is that firstly, if we are sorting start time, the problem here is that their elements are corresponding to each other. Like start time's first element is corresponding to end time's first element, and they are corresponding to profit's first element. So firstly, we need to make a vector which is consisting of the tuple, or we can say a vector of these three values from each of the arrays. So let's just make a new array or vector of vector int, and that is our, let's say, temporary vector, which is basically storing the job data. Job data is what? Start time of the job, end time of the job, and profit we are gonna get for this job. So let's say int n is equal to any of it, like profit dot size, they are all of same sizes. Okay, now for int I0 to I less than ni plus plus, and its size, let its size be n. Okay, now temp I will be what? It will consist of three values: start time I, because we are gonna sort it according to start time, so that's why it's been taken at the first place. Then the end time I, then the profit I. Profit I. Okay, now we will just sort this temp dot begin to temp dot, I think there's a problem with my keyboard, it's printing the things two times. Fine. Now if we have sorted the arrays, what else we are gonna do is see what we planned was, oh sorry about that. Yeah, what we planned was we will call a function with the first index, correct? So before that, let's sort the start time array also, because that needs to be sorted. We are still not clear about how to find that index where we should insert this end time of that job. Okay, so we sorted this. Now we will call the function for it. We'll just return let's say function, and it will be consisting of initially 0th index, the temp array of arrays, the start time, because in this array we need to find start time, in start time we need to find a location, so we need this array. And apart from that, then, and yeah, dp forgot. Let's just make this vector int dp size is n, and initially elements are -1. Fine. Now what about the function is that it will return an integer, and if it's return an integer, what are the arguments are int I, index, temp. We can just take this and here and reference it. After that we have a start time, so we can just do this and do this. After that we have starting again int n and vector int dp, int and dp. Yeah, these are the arguments. Now if at any moment I is greater or equal to n, then we will just return dp. No, we reach somewhere where we should not reach. If we reach at n, we will return 0 obviously. N is not out of bounds for the arrays, right? So if I is greater or equal to n, we will just return this. If dpi exists and it's not equal to -1, which was the initial value of that position, we'll just return dpi, that it already exists, brother. You don't have to calculate it again. This is called memorization. Now what will be the next thing is that, let's say if we now what we need to find in the start time array was the index where the end time of the ith job can be inserted, because only after that we will pick up a job. So let's say that index is idx, and I'm still not sure how to calculate this. Let's just keep it empty for now. Let's just say we have found that index where we should insert the end time of this ith start time. That only after that we will pick up the next job. And how do we pick up the next job? We pick up a start time for it. Okay, end time we know for it already, and once it ends, only after that time we will pick up a next job, right? So now there are two options, and we pick this job, take or pick this job. And okay, and another thing is we do not pick this job. Two values are there, and return statement will be dpi for this, and dpi will be what? Dpi will be max of pick and not pick, because we have to maximize the profit. Whichever gives us the more profit, we will just go with it. Okay, now these are the three things what we need to do here. See, let's say we pick it. If we pick this thing, then obviously we will add the profit of this job to the answer. How do we do that? Temps ith, and what is the profit in this? Third element is the profit of temp. Okay, in the ith job, third element, sorry, index is 2. Okay, plus we will go to the next index of the start time, that is, we'll call the function again. This will be idx, because this is the index just next to the end time of the current job. Okay, if we pick up this end time is the current job, then anything in between start and end time of this job we cannot pick any job in between from there. Once the end time, we know that we have the end time. Once the job ends, only after that, if any job is there who is starting after the end of this job, we can pick that up. Okay, we will check for that. So idx, rest of the things will be same, like temp, start time, n, and dp. Fine. And if we do not pick this job, we will just go to the next element of the start time array. And that's just simple as that I plus 1, we will just take this, rest of the things being same, so we can just copy them out from here and paste them here. Fine. Now this index thing comes up. How do we find this index? See, we have to find this index. If we pick up one first job, we know its end time is 3, and between 1 and 3 there is no job that's relevant to us if we pick up this job, because after 3 only after that we can pick up new job, and only after that the jobs with the start time later than 3 are eligible for this. So it should be here. After that 3 these two, from these two jobs we can pick up anything. So let's just say, uh, how do we know for an element that we have one element and we have to find out the element equal or just next to it? Means if we can find out, uh, if we can find out the element just bigger than a specific element, just bigger than a specific value, bigger or equal to, means the first value which is not less than our value, the first element which is not less than our value, the first element which is not less than 3, which is equal to 3. Okay, so this will be the element we have to reach here. So ring a bell. थोड़ा सा आया कुछ दिमाग में? What are we talking about here? Like if we are using C++ and we don't know about lower bound and upper bounds, surely we are living under a rock, because these things are really useful in such cases. See, where we have to find the element just equal or bigger than 3 in this array, or in other language we can say the first element in this array, sorted array. Upper and lower bound only applies to sorted arrays. Okay, so in other language what we said, either we have to find the element which is equal or bigger than the specific element we have, that is 3, or in other language we can say we have to find the first element of this array in the sorted way which is not less than 3, which is not less than 3 means it may be equal to 3 or greater than 3. So that means that we have to find at least equal or greater than 3, which is this. We have to find this index of this array. So we have to apply a lower bound here, and if you don't know about lower bound, you can study about it and you should know the syntax of it at least. So its syntax is basically this, that first thing, lower bound and upper bound returns iterators, whatever you say that, not indexes, integer indexes. Okay, they do not return that. So how does it work is that in which array we have to find start time dot begin to start time dot end, we will go. What we have to find, third argument will be that. What we need to find, we need to find temp I1. This is the end time for this ith job, you know, right? So this we have to find. This will return us a iterator, but we need an integer index. So what will we do? Simple thing, if we know about this, we will just minus start time dot begin. If we minus this iterator start time dot begin, it will give us an integer value, and of that index, which is first element which is not less than this. Fine. So I guess it's clear now, and yeah, it should be fine. The answer looks correct to me. Let's just try running it. And I don't think like there can be a simple explanation than this for this question. This is the most simple explanation I can think of for this question. There may be other ways, but I'm not sure they are simpler than this or not. But this is really simple. There are also ways we will be sorting it according to the end time, then approaching the question somehow. There are ways like that, but I think this is really good way to do this question, because this is the first thing in our mind comes is sorting with the start time. Okay, that if we start a job, we will pick up next job only after this job has ended. So we will pick up that element of start time which is just greater than the end time of the previous job. If we pick it, if we do not pick it, just pick the next element in the start time and go with it. And whichever gives us the maximum profit, we will store it in the answer of that case. And if we already have the answer of a case, we will just return this, because we are calling recursion here. That might happen that it will come again and we have to calculate the things again. So to just remove that redundancy, we are introducing this memorization here, and that's how we do this. This is similar to the coin change problem, but we have used the recursion approach here, not just the 2D DP and for loop things. That's much easier to understand. See, do not go in depth of recursion because recursion does its jobs. Just think of recursion for the edge cases, okay? For the edge cases, you need to see, and for the small cases, you can understand the recursion. But if you try to go deep into the recursion, try to find the explanation for large cases, you will just lost in making the tree of it, that this is a function call, then this calls this, then this calls this. Don't go in all that, just know the concept that what is happening. Recursion is basically what it's a, whenever it's call it, the call is stored in that stack, and what happens in the stack is that what which call is the end of the recursion, that will give us the first result, because in the stack whatever enters at the last will return the value first. Okay, so basically when we call recursion, there is a call stack which is in the memory, and every function call is stored in that stack, 1 over 1 over 1. So the function call which was made at the first time initially will give us the answer at the end. So before it will firstly solve all the above function calls. So don't go deep into that, just take a small case to understand recursion. Yeah, you got it. After that, go for the bigger cases. It will easily handle itself. Recursion will never like give the wrong things or wrong answers. You can trust the recursion. Okay, so this is how it can be done, and yeah, we have submitted it. This was really good question, I must say, like one of the best question I can say, which I have seen in past few days, like 22 days. I can say this is the best question, and the reason behind is also that I was able to explain this thing so good that even I am surprised that that was a really good approach, and I could make I can hear myself, so I can say that I was a really good orator in this question, and that was really good. Okay, I don't know what to say, but yeah, that was good. So I guess that's enough for today, because if we pick up the next hard question, which is find median from this data stream, let me just read it. The medium in this median in the middle value of our range, yeah, okay, ordered integer list. If the size of the list is even, then there is no middle value, and the median is the median mean of the two middle values. Fine, we know that. So implement the median finder class. Median finder initializes the median finder object where addNum added an integer. Okay, this is the order list. Keep in mind, median is the ordered list, and then we have add number and then find median. Two functions are there. We have to implement these functions, like मीडियन फाइंडर कॉल करेंगे पहले, फिर एक नंबर ऐड करेंगे, फिर एक नंबर ऐड करेंगे, फिर उनका मीडियन निकालेंगे. जैसे 1 ऐड किया, 2 ऐड किया, फिर उनका मीडियम निकाला. मीडियन क्या आया? इज इट गिवन देयर? नो, इट्स नॉट. 1.5 आया. फिर उसके बाद हमने एक और नंबर ऐड कर दिया, 3 ऐड कर दिया. अब मीडियन क्या आया? 2 आया. तो इस तरीके से है हमारा ये क्वेश्चन. दैट्स लाइक नॉट अ really tough question. So let's just 43 minutes have been already gone. Can we try this? Just a second. See, it's 42, 44 minutes. So I will. Can we do this in? If we can do this within 1 hour, we can go for this. Yeah. Okay. Yeah. Let's try to find an approach for this. See, uh, do not go like whenever we get an element, we will sort the list and find the median. That's not how we're gonna approach this. Obviously not. we have to do something else. Okay, so what we can do here is, I know that there must be a lot of approaches, but see, we are getting one element. Okay, uh, mhm, any coming element will be pushed in the array. We have, do we need to have an array, or what approach we can take in this is, okay, yeah, okay, so I don't have a, like, I can't come up with any approach right now. Obviously there's a brute force approach, but we are not gonna do this with this. So let's do it tomorrow only, because only 40 minutes are remaining and solving it and explaining it will be hard. So let's go for it tomorrow only. So that's it for today. We did two really good questions today and I'm feeling really good now. Okay, so that's it for now. We'll meet day 23.